Good afternoon, dear colleagues. First of all, I'd like to thank Rakros for a wonderful conference on this beautiful island. Everything's great. Thank you for the opportunity to spread the word about DigitalGlobe to a wide range of pros from all over the world. I will tell you about how growing our constellation will contribute to your business growth. First of all, a few words about DigitalGlobe. At a glance, this is a public company with shares on NYSE. We have headquarters in Colorado, in the city of Long. Staff includes number of employees includes more than 1,000. DigitalGlobe owns and operates the most advanced high-resolution satellite constellation: Iconus, QuickBird, WorldView 1, GEO1, WorldView 2, and WorldView 3 now. Thanks to this constellation, DigitalGlobe is the leader in optical remote sensing. At the moment, the cumulative archive is equal to 8 surfaces of Earth. We have 6 satellites, and we can update 80%. We can refresh 80% monthly. DigitalGlobe sets the standard of remote sensing quality that applies to accuracy, currency, completeness, and consistency. Next to our closest competitors, we are in the lead in terms of revisit, coverage, and archive. The launch of WorldView 3, the first commercial super spectral satellite, was a big highlight for us. This is the first multi-payload super spectral satellite with high agility platform and chromatic resolution of 31 centimeters. This is the video of WorldView 3 launch obtained from WorldView 1. A series of images, actually. And one more time. WorldView 3 was put in orbit on August 13th from Vandenberg Air Force Base.
And before that, we abolished the previous restriction. Now we're starting a new resolution permit, and then we'll start a 30 centimeter resolution for panchromatic. Some of the WorldView 3 products are still at the stage of calibration development, but soon we expect the first successful examples are going to be published from WorldView 3. WorldView 3 satellite is built on WorldView platform. It has a main payload, which you can get panchromatic multispectral band acquisition and 12 channels of atmospheric corrections. Orbit of the satellite is 615 kilometers and 31 centimeter for panchromatic, and for multispectral bands 1 meter 0.24 centimeters. For 8 bands of infrared, it's 3.7 meters, and 12 atmospheric channels have the spatial resolution of 30 meters. The swath width is about more than 16 kilometers. The productivity is 680,000 square kilometers per day. Geolocation spec week is expected to be up to 5 meters without any ground control points. The design life is more than 7 years. The expected life is 10 to 12 years. Mass of the satellite is 2,800 kilograms. Image downlink 1,200 megabits per second, or if it is done simultaneously with imaging, it's 800 megabits per second. Worldview 3 is an improved twin brother of Worldview 2. Still, we have high spatial resolution, efficient data acquisition. Improvement compared to Worldview 2 would be new bands in the shortwave spectrum, correction of atmospheric, 50% increase of the speed of data transfer, and better spatial resolution with the same swath breadth. It carries the same payload, and 0 to 8 bands would be multispectral instrument, 1 to 9 instruments, or 21 would be superspectral, and everything above 21 is hyperspectral. Its channels are panchromatic, 8 color multispectral channels, and CARIS is also aerosol, water, vapor, ice and snow atmospheric correction instrument. Here you can see the example of positioning the short wave bands in the atmospheric penetration area and improve spectral diversity with the simultaneous improved spatial resolution help us to apply it in various industries, also for the Ministry of Defense, Ministry of Agriculture, for forestry purposes and monitoring of emergencies, bathymetry and others. Now I'm going to show you an image acquired from Worldview 3 recently. This, I'd like to note, is a resolution of 40 centimeters, but acquired based on the 30 centimeter image acquisition. I'd like to make a comment about some of them. High level of detail helps us distinguish objects which were simply indistinguishable earlier for commercial satellites. We separately can see the wooden logs on the wood carrier, and you can see types of cars. You can tell car from a van from a truck. Another example, you can see here that car door is open. You can calculate the number of cars in the parking lot. You can see the seams on the cowling of the airplane, which was never seen on previous satellite sensors. And I'm not going to comment everything. These images are accessible at our webpage. They can be downloaded, but they're in JPEG, if I'm not mistaken, but they're still viewable. And for partners, we can offer real images which can be downloaded from the partnership portal. Brazil. Again, I repeat, there are many of them, but they are worth seeing once again. France, China, geological surveying, large trucks. Here you can see car tires. You can even calculate their number here. And the final part is would be pictures from New Zealand. High level of detail, you can see all the containers. Now I'd like to speak about the information, the data acquired from DigitalGlobe. Then we'll speak about the use of the data for forestry and application of DigitalGlobe data for agriculture. DigitalGlobe images are perfect for monitoring forestry stress, health and forestry inventories, precision farming, monitoring of crop stress, and so on. At the same time, there is a possibility of integrated analysis, which includes processing of stereo pairs, which is ever more relevant in view of the launch of Worldview 3, which can acquire the spatial resolution of 40 and in the future 30 centimeters, which increases greatly the productivity for acquisition of data in stereo mode. Here you see some of the examples of data analysis levels of interest, same image, for instance, forest and illegal logging, new plantations, and application of multispectral bands when analyzing the image. Here's another example from Mexico using different spectral bands. Actually, this image uses a band which is not accessible at other satellites. Segmentation of the image for better calculation of the diameter of canopies of trees, and this is again illegal logging site. You can identify types of trees based on their multispectral properties, identification of sites contaminated by pests, new plantations, segmentation, and mapping based on types of trees. This is the result of interpretation by taxator of worldview data. Worldview 2 in our case here. Now these are the results using stereo imaging. In 2013 a pilot project was implemented with our partners of Zond, and the purpose of that project was to get stereo pairs for different geographical regions of Russia in a short period of time, and confirmation of the possibility of production of stereo images for taxation registration. And the prospects for this would be object-oriented interpretation of space images, for which we need a big number of spectral bands. Again, we're talking about Worldview 2 and Worldview 3 applications. Another example is mapping results. In our case, this is the density of a forest. Another example, 1 to 5,000 scale. Another thing I'd like to discuss with you is the use of DigitalGlobe data in agriculture. Ministry of Agriculture set a task on drawing boundaries of fields and identification of different types of grains or crops growing there. We selected 2 test sites, one in Krasnodar, another in another region. The medium image is classified image with 23 classes of images with also water resources, and below you can see borders of different fields. They're color coded so that you could see their boundaries. Same that was done for the Moscow region. You can see on the below image that the number of fields are not so many, and black fields are the ones which have not been classified. Here you can see vector file with the boundaries of the fields. I must also mention 3D. 3D is a mainstream in remote sensing at the moment, and now DigitalGlobe, along with its information partner SAP, develop a speed building of digital elevation model and digital terrain models based on high detailed imaging, and this is a fully automatic process which doesn't require any other digital models or digital terrain models or ground control points. The image is built not based on the stereo but based on archive. We can build the DSM for any territory of the globe when there are a number of images. So we built a pseudo stereo. The sub company provided a number of sample images, and they insist that globally, all over the world, the spherical error, this is the term which is used by SAP, is not more than 6 meters for the whole world. So that includes 3 coordinates, X, Y, and Z. A few examples: Syria, Iran, Rio de Janeiro, Moscow, Beijing, Tripoli, San Francisco. So the more images, the better is the quality of the image. Here we used about 140 different images. London, Yes. Moving on, I simply must mention the subject matter of our services on the image delivery. DigitalGlobe has a mapping service which opens access to high-resolution images, which is called Basemap, but I'm not going to tell you about it. I'm just going to tell you about new things in that service, new add-on to this. It's a premium layer called Plus Daily. It allows the user and customers to acquire images from QuickBird GUI 1, Worldview 1, Worldview 2, and soon Worldview 3 in online mode in a matter of 48 hours. Here you can see the coverage rate in 30 days, and the images are uploaded to the platform of Basemap on a daily basis. It's about 1 million square meters on a daily basis, and the customer has access to all this information. They are fully processed images with a typical set of metadata. I would like also to know that at the same time the customer doesn't control the imaging. He can collect only what satellites acquire. And the second layer, it's called Plus Vivid. It is a layer which opens access to cloud-free, seamless, author-transformed mosaics for a whole country. To your left, you can see a set of images of some geographical area. You can see it was acquired at different points in time, and there are differences in tonality and lighting. But the Plus Vivid layer can rectify all of it, and we get an ideal 50 centimeter background map for the whole country. Here we see the same places in bin cards and Google Maps. Here is another example for the whole country. These are United Arab Emirates. Green color shows those countries which are already prepared. They're done with, and the blue color is something that we expect to finish by the end of the year. The last thing I'd like to talk with you about is our crowdsourcing approach to data analysis. Here you can see the image of a city of Murd after tornado hit it, and our task was to identify what houses were destroyed and which houses lost their roof. Only one expert could do it. One expert can do it in 5 working days. 2 people can do it more. But what if hundreds, thousands, or like with the lost Boeing, millions of people will be doing this? DigitalGlobe is processing information that we receive from each user of the community who interpret images, and using special statistical model we identify how accurate and applicable the data are for subsequent use. And we can process this image in a matter of hours, even 1 hour. We know exactly where the buildings are destroyed, which buildings lost their roof, and we can calculate economic costs. I specifically mention it because now, perhaps you know that in Russia we lost a helicopter in Tuva. I've been looking for it for a number of days, and together with the Minister of Emergency Situations, we decided to apply this approach. Now, we already received preliminary coordinates of the place where the helicopter crashed. We cannot acquire images there because it's cloudy there yet. And then we're going to upload these images to TomNot, to the crowdsourcing analysis system, and everybody will be able to participate in this interpretation. Hopefully it will happen in the course of this conference, and then I will be able to report about the results right here, to show the results, and maybe together we can find this helicopter. That's all I have to tell you. Again, I would like to thank the company Rakurs for the perfect opportunity to tell you more about DigitalGlobe. Thank you. I'm ready to take your questions now. Большое спасибо. Thank you very much. I see some questions from back there. Valery Zaichka, Roscosmos. I have a question. You said that you're going to submit images to the Minister of Emergency Situations. Is it for free or commercially? We're not going to disseminate images. We are going to open access to this platform. And the Minister of Emergency Management, they're not going to get the images. They're going to get vectorized files with the possible coordinates of the helicopter crash. They are not going to get the images. Okay, any other question? If there are no more questions, then thank you very much.